Ncert Chemistry, Unit 7, Alcohol, Phenols and Ether. Preparation of phenol. What is phenol? Hydroxyl group attached to the aromatic benzene ring directly is called phenol, where OH group directly attached to the benzene ring. Formula C6H5OH. One of the hydrogen atom in the benzene ring replaced by the hydroxyl group aromatic alcohol. Phenol, the other name of phenol is carbolic acid. In earlier days, phenol commercially prepared from the coal tar. Nowadays, the phenol can be synthetically prepared in laboratory. So now we are going to see the 4 methods of preparation of phenol according to this book. From haloarine, from benzene sulfonic acid, from diazonium salts and it from cumene. The first method from chlorobenzene, haloarine. Chlorobenzene, where chlorine attached to the benzene ring called haloarine, fused with the sodium hydroxide, heated with sodium hydroxide at the temperature of 623 Kelvin and the atmospheric pressure of 300 atmospheric pressure. So it forms sodium phenoxide. The sodium phenoxide and acidification with the hydrochloric acid, sodium and chlorine reacts, remove the sodium chloride, and then electronegative oxygen, the H substituted in the place and joined in the place, it form on acidification, sodium phenoxide on acidification, it form phenol. Like that of sodium hydroxide, it is sodium phenoxide, phenol. So the conversion of chlorobenzene into phenol. How to get phenol from chlorobenzene? So this is the method. Next one is from benzene sulfonic acid. Benzene sulfonic acid. How to get benzene sulfonic acid from benzene? So the benzene, when treated with oleum of the formula H2S2O7, sulfonated, it sulfonated and sulfonation, it formed benzene sulfonic acid, which on treatment with heating with molten sodium hydroxide. So here the OH gets substituted in that one of the hydrogen. Instead of that hydrogen, it forms phenol. So conversion of benzene into phenol by using oleum from benzene sulfonic acid. The second method. From benzene diazonium salt. What is benzene diazonium salt? C6N2Cl. Benzene diazonium salt. How to get phenol from benzene diazonium salt? Hydrolysis of benzene diazonium chloride will give phenol. How to get benzene diazonium chloride? Aniline, CH5NH2. Amino benzene is called aniline. Aniline on reaction with sodium nitrate and hydrochloric acid, it will give nitrous acid, HNO2. On ice cold mixture of sodium nitrate and hydrochloric acid, the temperature of 273 to 278 Kelvin, it gives nitrous acid that converts the amino group into benzene diazonium chloride, CH5N2Cl. So this on hydrolysis, the N2 group N2 gas evaporated, and here the Cl, one of the H and the Cl reacts forming HCl. Instead of that N2 group and this OH group gets substituted, it forming phenol. So hydrolysis of benzene diazonium chloride gives phenol. The amino aniline on with nitrous acid, it gives benzene diacetation. This reaction is called diacetation. Conversion of amino group into benzene diazonium chloride is called diacetation. The benzene formed diazonium chloride on hydrolysis gives phenol. Next one is synthesis of phenol from cumene. What is cumene? 2-phenyl propane is called cumene. Cumene on air oxidation gives cumene hydroperoxide. An oxidation of cumene, that is 2-phenyl propane or isopropyl benzene. In air oxidation, it forms cumene hydroperoxide. Then cumene hydroperoxide on hydrolysis, treating with dilute acid, it forms the OH group get attached with the benzene group, it forms phenol. That the subproduct is acetone, the acetone get removed. So the phenol, cumene on air oxidation, it forms cumene hydroperoxide. It on hydrolysis with the dilute acid, it forms phenol and acetone. So laboratory preparation of phenol. From haloarine, conversion of chlorobenzene to phenol. From benzene sulfonic acid, from benzene to phenol. From diazonium chloride, aniline to diazonium chloride, then into phenol. From cumene, 2-phenyl propane is called what? Cumene. So 4 methods of preparation of phenol. Acidity of phenol. The reaction of phenol with metals like sodium and aluminum, it forms corresponding metal oxides, and it reaction with sodium hydroxide shows the acidic nature of phenol. The hydroxyl group present in the phenol directly attached to the carbon atom in the benzene ring. The carbon atom is sp2 hybridized, possesses the electron withdrawing nature. It pulls the electron present in the oxygen atom of the hydroxyl group and makes the electron delocalization. Because of the movement of electron, the concept called resonance, due to the resonance stabilization, the formed phenoxide ion from the phenol is more stable than that of the phenol, causes the acidic nature of the phenol. Here the reaction of phenol with aqueous sodium hydroxide indicates phenol is stronger acid than alcohol and water. In the case of the alcohols and aliphatic alcohol, here the oxygen atom present in the methyl attached to the methyl group is in oxygen atom only. But in the case of the phenol, due to the high electronegativity of the sp2 hybridized carbon, the OH attached electron density decreases in the oxygen atom. So, due to the decrease in the electron density of the oxygen atom causes the polarization of the OH bond, results in the formation of the phenoxide ion. The formed phenoxide ion is more stable than that of the phenol. The formed phenoxide ion is due to the resonance stabilization, it's more stable than that of the phenol. It's responsible for the, so due to the protonation, the stabilized phenoxide ion and the protonation of the H plus, there causes the reason for the acidity of the phenol. And here the resonance stabilized the phenoxide ion, the delocalization of the electron is explained in and more electron density in the ortho and para position. And the electron withdrawing group such as the nitro group enhances the acid strength in ortho and para position, and the alkyl group decreases the electron density of the phenoxide ion, so resulting in the decreases the acid strength. The cresols, hydroxyphenols possess the less acidic than that of phenol due to the presence of the methyl group. Electrophilic aromatic substitution reaction. Electrophilic, electron loving nature. The electron density, electron delocalization present in the phenol. Here the electrophiles get substituted in the benzene ring of the due to the electron density, due to its electron density, called electrophilic aromatic substitution. Here instead of that one hydrogen atom present in the electron dense methylene group, some other electrophile gets substituted. Here the electrophile gets substituted in the ortho and para position. Because of that, the OH group attached in the benzene ring in phenol makes or directs the incoming group into ortho and para position, or it makes the ortho and para position more electron rich. So the electrophiles in phenol going to the get substituted in the ortho and para position. Nitration, the substitution of the plus NO2 group, nitro group at low temperature with dilute nitric acid. Here on nitration of phenol, dilute nitric acid at low temperature, orthonitrophenol and paranitrophenol is formed. Here orthonitrophenol, 1,2-nitrophenol, here the 1,4-nitrophenol, paranitrophenol is formed. Here the mixture of orthonitrophenol and paranitrophenol is formed, and here it can be separated from its volatility. Here the orthonitrophenol 1,2 position. Here the hydrogen bonding formed between the electronegative oxygen of the nitro group and the electropositive hydrogen within the molecule. Because of the extra hydrogen bonding, the boiling point of the orthonitrophenol increased, the hydrogen bonding within the molecule. In the case of paranitrophenol, hydrogen bonding formed with another molecule, one nitrophenol with the another nitrophenol. Here the OH of one nitrophenol paranitrophenol with the another paranitrophenol. So with another molecule, this cause of this bonding is called intermolecular hydrogen bonding. Within the molecule, it is intramolecular hydrogen bonding. Due to the hydrogen bonding type, here the volatility, the boiling point is different, which is higher than lesser. With this, we can differentiate ortho and paranitrophenol. Here with the concentrated nitric acid, it formed 2,4,6-trinitrophenol. On strong nitration with concentrated nitric and sulfuric acid, Here the phenol, it forms both ortho and para position get substituted. It forms 2,4,6 trinitrophenol is called picric acid. Picric acid is a powerful explosive. What is picric acid? 2,4,6 trinitrophenol is called picric acid and is used as an explosive. It is prepared by the strong nitration of phenol. So nitration of phenol. The next one is halogenation, bromination. So bromination at a low temperature like low polarity solvents like chloroform and carbon tetrachloride at 273 Kelvin, it forms a mixture of orthobromophenol and parabromophenol. The usual halogenation of benzene takes place in the presence of iron halides, iron bromides, which polarizes the halogen molecule. In the case of phenol, in the absence of Lewis acid, due to the highly activating effect of the OH group attached to the benzene ring. The next one is the reaction of phenol with bromine water. So phenol when reacts with bromine water, both ortho and para position get substituted. It forms 2,4,6 tribromophenol. That is one of the lab tests to identify the phenol. Phenol with bromine water, it forms a white precipitate. That white precipitate is 2,4,6 tribromophenol. What are the lab tests for phenol? Is phenols with neutral ferric chloride, it gives violet coloration. Phenol with bromine water gives white precipitate. That's phenol with white precipitate is 2,4,6 tribromophenol. That is the reaction explanation for the reaction of phenol with bromine water. Here there are questions are given. The mononitration of 3-methylphenol. Mononitration of 3-methylphenol gives ortho and para substituted product. Here the ortho and para substituted product 1,4 and 1,6 substitute product are formed. Dinitration of methylphenol. So methylphenol and dinitration, here also 1,4, 1,6 ortho and para position both get substituted. That is dinitration of phenol. Mononitration of phenyl methanate. So here the phenyl methanate mononitration gets a para position. To the phenyl methanate group, the para position gets substituted. So the explanation is given for this question. Next one is Kolb's reaction. What is Kolb's reaction? Is conversion of phenol into salicylic acid. Conversion of phenol into hydroxybenzoic acid, that is salicylic acid, is called Kolb's reaction. So orthohydroxybenzoic acid, salicylic acid is the Kolb's reaction. Here the phenoxide first treated with sodium hydroxide forms sodium phenoxide, which on upon carboxylation. The carboxylation with the carbon dioxide, the carboxyl group gets substituted in the benzene ring. On acidification, further acidification, the carboxyl group get acidified and it forms orthohydroxybenzoic acid is called salicylic acid or 2-hydroxybenzoic acid. So Kolb's carboxylation reaction, conversion of phenol into salicylic acid is called Kolb's reaction. The next one is Riemann-Tiemann reaction. Conversion of phenol into salicylaldehyde is called Riemann-Tiemann reaction. Here for that chloroform and sodium hydroxide is used. Here the conversion of phenol into salicylic acid, sodium hydroxide and carbon dioxide is used. Here conversion of phenol into salicylaldehyde, here chloroform and aqueous sodium hydroxide is used. Phenol reacts with the presence of aqueous sodium hydroxide and chloroform. It forms an intermediate like that ONA and CHCl2, which on further reaction with the sodium hydroxide, it forms here the CHCl2 group converted into aldehyde group. So substituted benzyl chloride is hydrolyzed in the presence of alkali. So this is intermediate benzyl chloride on hydrolysis with sodium hydroxide forms an salicylaldehyde, sodium salicylaldehyde, sodium salt of salicylic acid, salicylaldehyde, sodium salt of the salicylaldehyde. So here on hydrolysis with the acid, here the sodium salt hydrolyzed to acid OH group, so it forms salicylaldehyde. So hydroxybenzaldehyde, this hydroxybenzaldehyde is called salicylaldehyde. So Riemann-Tiemann reaction is conversion of phenol into salicylaldehyde in the presence of chloroform and aqueous sodium hydroxide. Riemann-Triman reaction, salicylic acid and sorry, Kolb's carboxylation, salicylic acid, and Riemann-Triman reaction, salicylaldehyde. Kolb's carboxylation of phenol with sodium hydroxide carbon dioxide, salicylic acid, and phenol with chloroform and sodium hydroxide gives salicylaldehyde. Next reaction, conversion of phenol into benzene. The zinc dust reduced phenol into benzene, and zinc dust reduced phenol into benzene and itself oxidized to zinc oxide. So conversion of phenol into benzene is possible when it is dissolved with zinc dust. Next one is oxidation of phenol. The oxidized product of phenol is para-benzoquinone, that is 1,4-diketone. The oxidizing agent used for the conversion of phenol is acidified sodium dichromate. So acidified sodium dichromate oxidizes phenol into 1,4-diketone, that is para-benzoquinone. So it's a diketone here with the mother product of OH, 1,4-dihydroxybenzene is called quinol. That ketone is called quinone, 1,4-diketone quinone. So oxidized product of phenol is 1,4-diketone, that is benzoquinone, para-benzoquinone. The oxidizing agent is acidified sodium dichromate. Subscribe for more videos. Thanks for watching. Thank you.